Welcome everybody. This is 10.6 related rates. So on the last section, 10.5, we were doing implicit differentiation with respect to x. In this section, we will be doing implicit differentiation with respect to time, because now everything is related to time. So we implicitly derive by d over dt for any equation given. So now we're going to get y primes and x primes. Okay, so that's what related rates is, right? So everything is related to some form of time in a given rate. So to solve a related rates problem, we wanted to determine the quantities that were given. Then this is when we're getting to the actual word problems. So determine what the problem is giving you. Find an equation, or usually given an equation, to relate these quantities. Differentiate both sides with respect to time, and then substitute any values that were given after we take the derivative, and solve for the remaining piece. So whatever we're solving for, x prime, y prime, or whatever variable they give us. So this is how we solve a related rates problem. Okay, so some key things to note. There's going to be some complicated looking notation. So like I said, last time we were deriving with respect to x, so we were saying d over dx. But today we're doing d over dt. So when you're working the homework, you're going to see something as in solve for d over dt of x, or it's going to say what is dx over dt. Now to keep these notes really simple, I just make dx over dt, I just write that as x prime. That's it. But if you want to keep using the dx over dt notation, because I mean that's what the homework has, that's fine. For the notes, I'm just going to keep it simple and say x prime, y prime. So same thing here, this would also be known as 2x dx over dt, or keeping it simple, 2x x prime, and so on and so forth. So these are the implicit derivatives of x with respect to time. So the implicit derivative of x is x prime, the implicit derivative of x squared, 2x x prime, the implicit derivative of x cubed, 3x squared x prime, and the implicit derivative of x to any power of n is n times x to the n minus 1 times x prime. So just in case you see this notation, and you will see this notation, so it likes to keep it as dx over dt. Okay. I guess I should rewrite this. And the same can be said for y. If it says find the implicit derivative with respect to time of y and find dy over dt, that means it's just looking at this. The implicit derivative of y with respect to time is y prime, or dy over dt. And 2y y prime would be 2y dy dt, and so on and so forth. So once again, the implicit derivative with respect to time of y is y prime, y squared, 2y y prime, y cubed, 3y squared y prime, and any power of n is n times y to the n minus 1 y prime. Now, I may be sounding like a crazy man, right? All these notations and everything. So just like I wrote it over there, if you see dx over dt, just know that it's x prime. If you see dy over dt, just know that's y prime. If you see any other variable, like p, dp over dt is the same as p prime, and just replace p with any other variable. Z, t, well, I wouldn't say t, z, t, r, m, whatever. It's always going to be that variable primed. So that's if we see those. So again, I do the prime notation because it just keeps it simple and less complicated to look at. Okay. So with that being said, let's go ahead and try finding a related rate. So all we're going to do is take the derivative with respect to time on both sides. So let y equal x cubed minus 3, and x prime is -2, and x is 2. So they're giving us values for x prime and x. And then it says find y prime when x is 2. So again, x is 2. So we do not want to plug anything in just yet. What you should always do is take the implicit derivative first. So that's what we're going to start. We're going to use this equation. And we're going to say d over dt of y equal to d over dt of x cubed minus 3. Okay. And then following the legend above, everything that's above on your paper, the implicit derivative of y with respect to time is going to become y prime. The implicit derivative of x cubed with respect to time is going to be 3x squared x prime. And the derivative of 3, no matter what whatever you're with respect to, the derivative of constant is always 0. So there is the implicit derivative with respect to time. All right, that wasn't bad. But now it says, go ahead and plug in -2 and 2 for x. That's all we want to do. So we'll say, what is it? X prime equals -2. And x equals 2. So this means you're going to get y prime equal to 3 times 2 squared times -2, which is going to give me 3 times 4, which is 12, times -2, we'll get -24. And that's it. That's all we want to do. All right. Let's try it again. So evaluate x prime for x squared minus 2xy minus y squared equal to 25 with the conditions y prime equals -1, x equals 2, and y equals -1. So what we want to do here is solve for x prime. So that's what we'll say when we start this out. Let's say so we're going to say, actually, I'll just keep it all the same color. Let me see. D over dt of everything on the left side of this equation, x squared minus 2xy minus y squared equal to d over dt of 25. And now we take the implicit derivative of everything with respect to time t. Okay, so what we're going to do here is let's ignore these two terms for now, because those are the easy derivatives. Let's look at the implicit derivative of this, because this is going to use the product rule. So let's just focus on this. So let me box this off. And this is going to use another implicit product rule of x, y. Okay, but remember, this time it's with respect to time. So I guess I'll write that here. Let me see. I'll say d over dt of x, y, which means that f will be x and g will be y. And now remember, when we take the derivatives, these are both derivatives with respect to time. So this means that f prime is going to be x prime, and the derivative of y with respect to time is going to be y prime. So these are derivatives, implicit derivatives with respect to time. So say okay, so we have that cleared up, and now we are ready to take the implicit derivative of everything else. So let's start back up, and we're going to look at the implicit derivative of x squared. Now, the implicit derivative of x squared with respect to time, so that's going to become 2x x prime minus this 2 out front. So now we're ready for the middle term where we just did the product rule. So you're going to have minus 2 times, and now let's go ahead and finish the product rule for those two terms. F prime g is going to give me x prime y plus g prime f gives me y prime x, but I'm going to rewrite it as xy prime. Okay, let's take a pause for a moment, because let's go ahead and save this somewhere to save you some time later on. So the implicit product rule of x times y is x prime y plus x y prime. All right, so save that somewhere. Well, it's on your notes. So that's where it's saved, right? And then we move on to the last one, the implicit derivative of y squared with respect to time. You'll get minus 2y, y prime, equal to the implicit derivative of 25. And the derivative of a number, no matter what, is always 0. Okay. Now the calculus is done. The rest is algebra on. So let's go ahead and solve for x prime like we said. So first thing is, let's go ahead and distribute that 2, that negative 2. So we'll have 2x x prime minus 2x prime y minus 2x y prime minus 2y y prime equal to 0. All right. So now we are still solving for x prime. So get your x primes together on one side and move everything else to the other side. So if you notice, we have an x prime here and an x prime there. There are no x primes over here, which means these terms will move over to the right side. So we will keep 2x x prime minus 2x prime y, and then add these terms over to the right side, 2x y prime plus 2y y prime. Okay. Now, where do I have more room? Over here. So we'll continue this up here. And now what you notice is that if you look at the left side, remember we're solving for x prime. So there's an x prime here and an x prime there, which means in order to solve for x prime, we can factor out an x prime. So that's what we're going to do on this step. We'll take out an x prime, and what that's going to leave me with is 2x minus 2y. I need to write smaller. X prime gives me 2x minus 2y equal to 2x y prime plus 2y y prime. And then all we have to do is divide by 2x minus 2y. And now we'll get our answer of x prime equals 2x y prime plus 2y y prime over 2x minus 2y. Now you see there's probably a common factor of 2 that we can cancel out. So let's go ahead and do that and finish up x prime. So I'll take a 2 out of the top, which gives me xy prime plus yy prime over 2 times x minus y. All right, one final cleanup. Those 2's cancel, and we get our final answer here. xy prime plus yy prime over x minus y. And here is the implicit derivative solving for x prime. Now all we have to do is plug in the values given above. Y prime equals -1, x equals 2, y equals -1. So let me write that down. So y prime is -1, x is 2, and y is -1. So we plug it into the above, and you'll get x prime equals x, which is 2, times y prime, which is -1, plus y, which is -1, times y prime, which is -1. Is that right? They're both -1? Yes. Over x, which is 2, minus y, which is -1. Okay. So this means that x prime is going to be -2 plus 1 over 2 minus -1, which turns plus, over 3, and we get -1/3 as our answer. Okay, there it is. So those are practicing implicit derivatives. So all you do is take the implicit derivative with respect to time on both sides, then just follow your legend that we have at the top of the page here, just to know how to handle the notations. Again, when I say handle the notations, let's say my math lab wasn't going to take this as an answer, then our answer would be dy over dt equals 3x squared dx over dt, which is definitely more complicated looking. Depends who you are, though. And then let's say my math lab wanted an answer for this one. You'd have dx over dt equal to x dy over dt plus y dy over dt over x minus y. Glorious looking, right? Okay. That's if it wants you to put that in. I think it just wants a numerical value, though. So no matter what, we get negative 1/3. Okay. Now on to the word problems. All right. Example 2, cost, revenue, and profit rates. Suppose that for a company manufacturing calculators, the cost, revenue, and profit equations are given by cost is 72,000 plus 60x, revenue is 200x minus x squared over 30, and profit is revenue minus cost. That's a given. Profit's always revenue minus cost. Where the production output in 1 week is x calculators. So X represents the number of calculators. If production is increasing at a rate of 500 calculators per week at a production level of 1,500 calculators, find the rate of increase or decrease in the cost, revenue, and profit function. Okay, so some things we have to pick out from this problem are the words. First is that X represents the number of calculators. So let's write that down. X is the number of calculators. And then the next thing they say is that production is increasing at a rate of 500 calculators per week. Well, this class is all about derivatives, right? Derivatives, when derivatives also mean slope or rate of change. So you see these words increasing at a rate. This means they're already giving us a derivative. So what this is saying is that they are giving us x prime. X prime is the rate of calculators being produced. Ooh, I'll rewrite that, produced. So they're giving us those numbers already. So this means it says that production is increasing at a rate of 500 calculators. This means that x prime is 500. And they are increasing at a rate of 500 calculators per week at a production level of 1,500 calculators. So this is giving us the value for x. So x is 1,500. So these are the values it's giving us. Now all we have to do is take the implicit derivatives of cost, revenue, and profit with respect to time. That's it. Let me rewrite that terrible word there. Okay. So first up is find the rate of change in the cost function, which is given above right there. So we're going to say d over dt of c equal to d over dt of 72,000 plus 60x. And now we're taking the implicit derivative with respect to time on both sides. So this means that d over dt of c becomes c prime equal to the derivative of 72,000. That's a constant. That's just 0. And then plus the implicit derivative of 60x with respect to time is going to be 60x prime. And clean it up. Let me write smaller again. One moment. Oh, actually that works. And now all we have to do is plug in the value for x prime. And x prime is 500. So I'll say and 60 times 500, we get 30, and then 1, 2, 3. So it's also smart to interpret our results. So if we got a positive number as the output, remember we're still talking about derivatives, we're still talking about slope. So the cost function, right? The derivative of the cost function gave us a positive output. So this means that cost must be increasing as we pump out calculators, 500 calculators per week. So all we have to say here is that cost increases. All right, so this means that if we produce 500 calculators per week, then our cost will increase by $30,000. That's it. Now we take the implicit derivative of the revenue function, which is right up there. So I'll write that. I'll say d over dt of r equal to d over dt of 200x minus x squared over 30. Okay, and now the implicit derivative of r with respect to time is r prime equal to the implicit derivative of 200x with respect to time is 200x prime minus the implicit derivative of x squared with respect to time gives me 2x x prime over 30. And the reason I can rewrite it like that is because x squared over 30 is the same as 1 over 30x squared. So all we're taking the derivative of is x squared, which becomes that, and you put it back over 30. That's it. Or to keep it really simple, you just have to take the derivative of the numerator. Okay. All right, there is our derivative. Now all we have to do is plug in for x and x prime. We can reduce as well. So I can rewrite this as r prime equals 200x prime minus x prime over 15. Because the 2 and the 30 reduce to 1 over 15. Okay, there's our derivative. Now, plug in x and x prime this time. So say at x equals 1500 and x prime equals 500, we get r prime equals 200 times 500 minus 1500 times 500 over 15. Okay, now we just have to calculate that. Let's see, do I have my calculator? I probably do. There we go. And move over here. I'll type it in just like I wrote it. 200 times 500 minus fraction button 1500 times 500 over 15. So exactly like I wrote it on paper. And we will get 50,000. And once again, we're looking at whether the number is positive or negative. This is a positive output, meaning the derivative is positive, the slope is positive. So this means that revenue increases. Okay. And now the last one is profit. And we're going to take the derivative of the profit function with respect to time. So there's a nice little shortcut to this. We say d over dt of p equal to d over dt of revenue minus cost. Okay. And what this ends up becoming is, well, first, the implicit derivative of p with respect to time is p prime. The implicit derivative of r with respect to time is r prime minus the implicit derivative of c with respect to time, c prime. And it just so happens that we have the value of r prime and we have the value of c prime. All we have to do is subtract those two and we're done. So this becomes 50,000 minus 30,000, which gives us 20,000. That's it. All right, and that's where we got those numbers from. We already found revenue, we already found cost. It's a nice little shortcut. And the last thing is, I guess, to interpret it. And since that is a positive output, this means the derivative is positive. This means the slope is positive. This means that profit increases. Okay. There it is, our first application. Let's keep going. Three, a retail store estimates that weekly sales S and weekly advertising cost X, both in dollars, are related by the equation S equals 50,000 minus 20e to the negative 0.0004x. The current weekly advertising costs are $2,000, and these costs are increasing at a rate of $300 per week. Find the current rate of change of sales. Okay, so again, let's find out what it's giving us. So it says the weekly advertising costs are $2,000, and advertising costs are given by X. So X is our advertising cost. You can't write. Which are $2,000. And then, so right there, weekly advertising costs are $2,000. And these costs are increasing at a rate of $300. Costs are increasing at a rate of $300. X represents cost, but now the cost is increasing at a rate. There's the key word, rate, which means they're giving us X prime. So rate increase. And it's increasing at $300. Okay, we have those pieces figured out. Now we can take this function and take the implicit derivative of it with respect to time. So that's where we're going next. We'll say, like always, d over dt of s equal to d over dt of 50,000 minus 20,000 e to the negative 0.0004x. Okay, so notice this stuff over here on the left. Okay, so one thing we know is that the derivative of e to the x is e to the x. That's given, we know that. Then we also learned the chain rule. We know that the derivative of e to any other function, using the chain rule, is the derivative of that function times e to the u. So the derivative of e to the u is u prime e to the u. But now we have something new since we have just learned about implicit differentiation with respect to time. So the implicit derivative of e to the x, no matter what function is being raised to, is going to be the implicit derivative of that function times e to the x. So it's going to be whatever the implicit derivative of the function in the exponent is, times the original function, e to the x. So we are going to be using this property on this e. So don't worry, it's not bad. We're going to get d over dt of s, which is going to give me s prime, equal to the derivative of 50,000, which is just a constant, so that's going to be 0. Minus, and now all we're worried about here is the derivative of this function. So this means that the 20,000 will wait on the outside. And now on the inside, the derivative of this function using this property, we're going to get that the derivative, the implicit derivative with respect to time of negative 0.004x is going to be negative 0.0004x prime times the original e function of e to the negative 0.0004x. That's it. That's following that exact property. So it's the implicit derivative of 0.004x with respect to time, which becomes negative 0.004x prime times the original function that's there. And now all we have to do is clean up. So we'll get s prime equal to, the 0 goes away, and now we have negative 20,000 times negative 0.004. I'm using my calculator, so sure, why not? So negative 20,000 times negative 0.0004. And we get 8. We'll get positive 8 at that. So this will give me 8x prime times e to the negative 0.0004x. And now all we have to do is plug in 2,000 for x and 300 for x prime. That's all we have to do. So let's do that on the next step. So we're going to get s prime equals 8 times x prime, which is 300, times e to the negative 0.0004 times x, which is 2,000. And now, type it in our calculator. I'm going to type it exactly how I wrote it on my paper. 8 parentheses 300. And to get to your E button, if you have no idea where it's at, you hit the second button or the shift button or whatever button it is on your calculator and look for the natural log button, the LN button, which on my calculator, if you look at the bottom left corner, it is the third button from the bottom. So I click the natural log button and I get E raised to an empty box. Now, in that empty box, I'll type exactly what I wrote. Negative 0.0004 parentheses 2,000. There it is. Whatever I wrote on paper is exactly what I put in the calculator. There you go. And then I hit enter. And we get $1,078.39. Okay. And of course, interpret, it's asking, find the current rate of change of sales. So advertising costs are $2,000 and costs are increasing at a rate of $300 per week. Well, if we're advertising correctly, then yes, our sales of retailers, our retail sales are increasing by $1,078 per week. So we can say here, sales increase. Okay, and it increases once again because it is a positive number. It is a positive derivative, a positive slope, a positive rate of change, positive, 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 increase, increase, increase. All right. Oh, we're doing good. Let's keep going. All right. 4 could possibly be the longest one. We'll see. The price P in dollars and demand X for a product are related by the equation X equals 7,000 minus 0.1 P squared. The current price of $100 is decreasing at a rate of $5 per week. Find the associated revenue function and rate of change in dollars per week of revenue. Okay, so it wants us to find a revenue function, take the derivative of the revenue function, and plug in the pieces that it's giving us. So right here, it's giving it away. Current price is $100. So this means they're giving us P is $100. And then it says the current price is decreasing at a rate of $5 per week. So if price is decreasing, this means they're giving us P prime, and they're giving us that it's decreasing at a rate of negative $5. Okay. Now, we have those pieces given to us. Now we need to find the revenue function. So that's step A. Now remember, revenue is always given as X times P. X is the amount of items times the price that we sell them at. Well, lucky for us, they give us an equation for X. So X equals all this information, which means that we're going to take 7,000 minus 0.1 P squared and plug it in for X, because X contains all that information. So what this becomes is we get parentheses 7,000 minus 0.1 P squared times P. Now just go ahead and distribute the P, and step A is done. We'll get 7,000 P minus 0.1 P cubed. This is our revenue function. Telling you, I'm trying to write today. Revenue. Okay. And then B, since we found the revenue, take the implicit derivative with respect to time. That's what we do in B. So B says d over dt of Rp equal to d over dt of 7,000 P minus 0.1 P cubed. And the implicit derivative with respect to time of Rp, R of P, is R prime of P equal to the implicit derivative of 7,000 P. This is going to be 7,000 P prime minus the implicit derivative of P cubed with respect to time. This 3 will come down and multiply the 0.1. So if you have 10 cents and you tripled it, you now have 30 cents. So you're going to get 0.3 P squared P prime. There's our derivative. That's done. And now if it wants the MyMathLab answer, then this is what you write. Actually, this is what we write. We'll say dr over dt equal to 7,000 dp over dt minus 0.3 p squared dp dt. Okay, and now all we have to do for C is plug in P and plug in P prime. So P is 100 and P prime is -5. So we'll say R prime of P equal to 7,000 times -5 minus 0.3 times 100 squared times -5. So once again, all we did was plug in 100 for P and -5 for P prime, or dP over dt. Okay. And calculate. Just like I wrote it. 7,000 times -5 minus 0.3 times 100 squared times -5. And we will get, so everything's right. And we will get that revenue is negative. The rate of our revenue is decreasing by -$20,000. Oof, that's a lot of money. Okay, and let's see. This says the current price of 100 is decreasing. Find the associated revenue function and the rate of change in dollars per week. Ooh, so this means that the revenue is decreasing by $20,000 per week. Not good. Revenue decreases. Okay. Last one. Yeehaw, okay? All right. A company's profit from selling X units of an item is P equals 0.3x squared plus $8,000. If sales are growing at a rate of $20 per day, find how rapidly profit is growing in dollars per day when 600 units have been sold. Okay, so once again, figure out what they're giving us. So selling X units of an item, and it says sales are growing at a rate of $20, not $20, of 20, this should say 20 units per day. So 20 units per day. So this means they're already giving us X prime. So X prime is the rate of units. And that is 20. And then it says, find how rapidly profit is growing in dollars per day when 600 units have been sold. So remember that X represents the number of units. So X is the number of units, and this means we have sold 600 units. So once again, all we have to do is take the implicit derivative of this function with respect to time, and you'll get d over dt of p equal to d over dt of 0.3x squared plus 8,000. And now the implicit derivative of p with respect to time is going to be p prime. The implicit derivative of 0.3x squared, this 2 will multiply that 0.3, so you have 30 cents, and you just doubled it. You get 0.6x x prime. 0.6x x prime, and the derivative of 8,000 is 0. So we don't need that. There's our derivative. Now take 600, plug it in for x, take 20, plug it in for x prime. That's all we have to do. So we'll say p prime is equal to 0.6 times 600 times 20. Calculator. .6 times 600 times 20, and we get 7,200. So it says, how rapidly is profit growing in dollars per day when 600 units have been sold? So if we have sales growing at a rate of 20 units per day, and we have just sold 600 units, this means profit is increasing by $7,200 per day. So all we have to say down here is profit increases, because once again, it is a positive number. So meaning you have a positive slope, a positive rate of change, which means we increase. Okay, that is related rates. Choose whether or not you want to stick with primes or the other notation, dx over dt, dy over dt, dp over dt, whichever you prefer. And that is it. Now, this should get us ready for the next exam. The test review is out, so let's get started on that. See you after the exam, I guess, right? Yeah, that was fast. All right.